Welcome to Chem Classroom with Auntie Taiwo. So today we'll be talking about oxygen. The last time we talked about water. Yes. So today we'll be talking about oxygen. We'll be talking about the group and the period in which oxygen belongs to, the physical properties, then some chemical properties, how oxides are being formed. Then we'll also be talking about the preparation of oxygen in the laboratory and the industrial preparation. Then we'll talk about tests for oxygen and also uses of oxygen. So now oxygen is about the 8th element on the periodic table. It has an atomic number of 8. So it has atomic number of what? 8. Then it has atomic mass of 16. So if I'm to break oxygen into shell, in writing the electronic configuration, I have 2, 6. Then if I'm to do the SPDF notation, I will have 1s2, 2s2, and 2p4. So I guess it's complete. So this means that oxygen is in what? Group 6, and is in what? Period 2. Yes. So this is one of the things we need to know about oxygen. And another thing is that oxygen is some of the most abundant elements in the atmosphere, about 21%. And it also contains about 89% from water. Yes, as we all know that water is what? H2O. Yes, oxygen is very important, even for our respiration and all that. Okay, now going to the physical properties of oxygen. Is a colorless, odorless gas. It is neutral to litmus paper. Then it is also slightly soluble in water. It's slightly soluble in water, it's not completely soluble in water. And it also liquefies at -183 degrees Celsius. That being said, now I will want to go to the laboratory preparation of oxygen. The laboratory preparation of oxygen can be done in about 2 ways. The first one is the decomposition of your hydrogen peroxide or the decomposition of the potassium chlorate. So I'll be using the potassium chlorate as a very good example. So you have the potassium chlorate here decomposing. So it will break. You have the potassium chloride plus the O2. That is the oxygen gas being liberated. Then the equation is not balanced. We find a way to balance. I'll put 2 here, put 3 here, then put 2 here. So we can see that the oxygen is being given off. Okay, then the industrial preparation of oxygen is being done through the fractional distillation of liquefied air. We have talked about separation techniques in the past, and the separation techniques, we can use it industrially in about 3 ways. Separation of our crude oil, I think purification of ethanol, then also the separation of what? The liquefied air. So we can also use fractional distillation for that. Okay, that being said, then we are going to the chemical properties. And when we talk about chemical properties, it has to do with the reactions of oxygen with some other elements on the periodic table. So now when the oxygen reacts with metals, our basic oxides are being formed. Example of your basic oxide is what? I have my Na2O, then I have my calcium oxide too, is a basic oxide. So basic oxide means that it can react as a base, react with acid to form salt and water. They have alkaline properties. Okay, so that is for the metals. Then when it reacts with non-metals like sulfur, like carbon, acidic oxides are being formed. acidic oxides are being formed. So you have your SO2, your CO2. So I'm trying to give examples of some of these our oxides, because at times you hear of basic oxides, acidic oxides. We also have what we call the amphoteric oxides. Now, amphoteric oxides, they are unique in their own way. They can act as a base. When they are acting as a base, they react with acid to form salt and water. Then they can also act as an acid. When they're acting as an acid, they react with a base to form salt and water. So either way, they can act as an acid, they can act as a base. They behave the two ways. So that is why they are amphoteric in nature. So when we say amphoteric oxides, examples are zinc oxide and the aluminium oxide. Okay, then we also have the one that we call the neutral oxides. You see this one? They are neutral to litmus paper. Yes. So neutral oxides, they are neutral to litmus. So you have your CO and your NO. This is your nitric oxide, and this is our carbon 2 oxide. They are neutral to litmus paper. So we'll call them the neutral oxides. Okay, now another thing that we'll be talking about also is how do you test for oxygen? You test for oxygen when you introduce oxygen in a glowing splinter, it ignites it. And this shows the combustion support of oxygen. In fact, without oxygen, combustion cannot take place. So it helps combustion. So it ignites a glowing splint. Okay, right there we'll be moving to the uses of oxygen. We use oxygen for respiration, of course. We breathe in oxygen and breathe out carbon dioxide. Then we also use oxygen for the production of our rocket fuels. We use it for in welding and in some industrial processes. Yes, then we also use it even in the hospital. We use the medical oxygen. We use it to resuscitate patients in the hospital. Then for respiration, of course, we have mentioned that. Okay, then the last thing I'll be talking about, okay, then oxygen is an oxidizing agent. Then for our oxygen, we have an allotrope of oxygen, which is the ozone. Ozone, yes. So ozone helps to protect us against the direct effects of the sunlight. So although oxygen exists in, you have the dioxygen, which is the O2 and the O3. So we have just two of this. Okay, so having said that, we have been able to talk about what oxygen is, the group and the period. We even have the SPDF notation, the laboratory preparation of oxygen, then the physical properties. We have said it, colorless, odorless gas, and it's slightly soluble in water. Then the chemical properties. The chemical properties also, I used oxides to explain, whereby you have the basic oxides, acidic oxides, amphoteric oxides, and the neutral oxides. And the allotrope of carbon, I said, is what? Ozone. Then we also mentioned the uses of what? Oxygen. Yes, the most important thing is used for respiration, for combustion, under welding. We also use it welding and cutting, then as what? Rocket fuel. So please, if you have not subscribed, kindly do so. Subscribe, like, and share. Tell your friends something is happening. Keep learning the nucleus of existence. Thank you.